Hello, everyone. Welcome to our virtual career fair, brought to you by NICE. We have a very exciting panel today talking to you about careers for statisticians in the high-tech industries. My name is Pyeong Liu, and I will be the moderator today. I will introduce our panelists individually before their presentations. Before we get started, I'd like to mention a few things about today's webinar. All attendees are view only. We will be collecting questions throughout our panelists' presentations. So if you have any questions, please enter them through the Q&A button. It is located in the lower half of your Zoom screen. And we'll leave the questions towards the later half of our webinar today. Without further ado, let me introduce our first panelist today, Dr. Amir Najmi. He is a principal data scientist at Google. He has worked at Google for 16 years. The last 6 years in Google San Francisco, he helped Google make better product decisions through cross-product data analysis. For the decade before that, Amir worked in search ads quality, where he also led the data science team. His technical interests include large-scale experimentation, prediction, causal inference, the role of human insight in machine learning, and in quality. Editor of the data science blog, he has been very involved in hiring for and developing the data science ladder at Google over the last few years. He has a PhD from Stanford University, where he studied information theory and statistics. Amir, the floor is yours.
Thank you, Pimu. I really appreciate it. So let's see. I don't use Zoom much, so if I make mistakes here, please forgive me here. Okay, so hopefully you guys can see that. Yeah, feel free to ask questions in the chat, and then maybe I can answer them as we're going along. So I decided to make the talk really practical. If you're interested in getting a job as a data scientist at Google, what would you do, and what would it mean to get a job as a data scientist at Google? So first of all, what is the title itself? So over the years, this has kind of evolved. Initially, like maybe before I joined, around the time I joined, there was no title. And so everybody was called software engineer no matter what you did. Eventually, we got a new role, and it was called Decision Support Engineering Analyst. And that's a mouthful, but it was actually very descriptive. It's kind of like if you go to a Chinese restaurant, it says it's like eggplant with spicy garlic sauce. It tells you exactly what it is. It doesn't, it's very clear, but it's a mouthful. And so that's how I was hired. I was hired as a Decision Support Engineering Analyst. And I'll explain a little bit what the duties of that role are. And then eventually evolved to something called quantitative analyst, which was a little shorter. And then just, probably about 5 years ago, we finally decided, okay, we'll call ourselves data scientists. And we did this with some trepidation, because the word data scientist is rather broad, and it has gotten more and more broad over time. So there was a question at some point, just a couple of years ago, we asked ourselves, should we fight to retain meaning in the term data scientist, or should we just move to a different title, as many of my colleagues in different industries have done? But we decided, no, we're going to stick with that. We're going to call ourselves Google Data Scientists, which means something very specific to us, just like Google Software Engineer means something very specific to us. I worked as a software engineer in other companies in the past, but I would never call myself a Google software engineer because the bar is too high for me there. So hopefully Google Data Scientists can also have an analogous meaning of that nature. Okay, so what does a Google Data Scientist do, in particular at Google? And I guess we'll hear from other people from the industry, and they probably have slightly different meanings for the term. So in this particular case, it basically is to support data-driven decision-making, and this decision-making is usually under uncertainty. Uncertainty is where statistics and data science comes in, because we're looking at data and there's some uncertainty associated with that. And so these individuals typically work in engineering teams, not always, but mostly. And the kind of, their charter is to help the company and their teams make better product decisions. So I just gave some examples here. It could be anything really. It could be, does this particular change I'm about to make, is it good for my users if I'm changing this product? Or let's say we've got an ML algorithm and it seems to score pretty high on cross-validated data, what have you, held out data, but does it really generalize well? And here generalization is going to be beyond the training set. Sometimes the deployment scenario could be different. And so how much do we trust this? Do we believe it's going to work okay? Or how much data center capacity do we need in 3 years? That's kind of, a very different type of question, but it requires a lot of understanding of where we are, where we think we're headed, all of that. So that's another decision that's uncertain in some sense. And how do we define and measure quality of, for example, search results? So measurement of quality, defining quality, that's a pretty big part of what lots of data scientists do. It doesn't have to be in search, it could be in different parts of the company. Okay, all right, so how do they actually approach their work? And usually we're asking for them to do really in-depth analysis to answer these questions. Obviously they have to be quantitative, not based on to the extent possible, based on quantitative measures. And we're expecting them to have a fairly deep and thoughtful, considerate judgment about these questions, right? So not just very narrow, but usually it's a broader understanding. And I should also mention that, if I'm doing coding and things get too complicated for me, I can always give it over to somebody, say, hey, I'm not a software engineer, somebody else is a software engineer, maybe they can solve it instead of me. It's too hard for me. But when it comes to a data scientist, I can't punt the question of statistical complexity or analysis to anybody else. I mean, we are the experts and we have to answer the question. There's no other group to go to. For example, research or something. No, we have to answer it. Now, this kind of in-depth approach only makes sense if the stakes are high. So we don't usually employ data scientists for small-scale stuff. We ask them to do it. We employ them for problems that really matter to the company. And this differs from. I should mention this differs a lot from the traditional statistical consultant role. So, sorry, I'm going to adjust my camera just a tiny bit here. Okay, maybe that made a difference, maybe it didn't. Anyway, so when I was in graduate school, we had this notion of statistical consultants. In fact, as graduate students at Stanford, we could participate in a statistical consulting course where people from different departments would come to us, tell us what they're doing, and ask us for help, and we'd try our best to help. And some faculty also involve themselves there. That's a very different role than the data scientist role that we have at Google. And the big difference is that, two things. One is that there's a lot of context and domain knowledge required to answer deep questions. And a statistical consultant, any consultant, kind of can only have a high-level view and speak in generalities, or have a very abstracted question given to them that they can answer. I worked with actually professors, famous professors in colleges while I've been at Google, and any analysis they do is conditioned on the CSV file you give them, right? So much happens in taking the data that's usually very complex and reducing it into something that fits in a nice CSV, because they're not doing big data usually in statistical consulting. And so much has happened there, so many decisions have been made that we think that that's probably not a great understanding. It's a much narrower approach. A lot has to happen to understand the data in all its complexity. So that's why we want people who have engineering skills who will engage with the data directly. And usually it's rather large. So that's why you have to have some programming skills for that. So that's the difference I wanted to make between the statistical consultant role. The nice thing about statistical consultant role is that you can sort of talk to people and you can say a few things and they get really impressed, and that's wonderful. But I mean, this is a different role. This is where you kind of live with the team, you understand the domain, so it's a bit different. Okay, so what does a Google data scientist do in terms of how they interact with other people? And one of the key things is that, you know, there's a business need usually. When I say business, it doesn't have to always do with money. It has to do with the organization that the data scientist is part of. And they have to keep an eye on what we're trying to do. They often work very closely with product managers. Product managers are the people who own the sort of the soul of the product or the project. Why are we doing this? Why does it matter? And you know, all of that kind of stuff. And so there's a kind of overlap between the product manager and the data scientist. The data scientist is focused on the end goal because when they're using their judgment to help answer questions, decisions that have to be made, they have to keep that end goal in mind. Otherwise, the decision is not an abstract decision. It's really based on the goal of the project. So that's kind of important. So one nice thing about being a data scientist, I would say, in the Google sense, is that you're naturally seen, if you're good, you're naturally seen as a thought leader. And the reason for that is that your approach is kind of holistic, because you're looking at the data in all its ugliness, right at the root of it. At the same time, you're connecting it all the way to the goals of the project. So, you know, you probably have more breadth than pretty much anybody on the project if you're the data scientist there. You're seen as impartial because your job isn't to make the decision. Your job is to present the decision to whoever the decision makers are in the best, clearest, most balanced way. So, and you're respected. Part of the thing is that you have to have credibility and you have to maintain that credibility, because your job is to make sure that the best decisions are made. And in order to do that, you have deeper insight into all the various factors. So if you conduct yourself with appropriate impartiality and all those things, you will have a lot more credibility than somebody who's seen as wanting to see a particular outcome. And many times, you know, different people have different opinions. They think this is going to be good. You say, well, here's the data on that. I'm not sure how good that is. And, you know, it's not your job to sort of force a particular outcome. So that's kind of nice about it. Okay, so the role I described, now to slight confusion here, the role I described is what we're calling data scientist in engineering. And if you were to, you know, go to careers at Google, you search for data scientists, this would be one of the things you'd see. It's not the only thing you'd see, because there are other roles at Google where the term data scientist creeps in, which are different. I just wanted to point that out to you. There's a marketing data scientist role, for example. I just did this last night, just check. There's a business data scientist. I'm not describing those roles. Those are different. So this is an engineering data scientist or data scientist in engineering. There are also other data scientist roles outside of Google and some inside Google, which overlap a little bit, or other companies often have an interpretation of the term data scientist that for us would be slightly different. For example, there's a business analyst or product analyst role at Google, which might be closer to some definitions of data scientists that you'll see in the industry. So that's more coming at it from a business perspective, more likely to have business experience and business background than to, for example, to have a statistics degree. Not necessarily, but that's more likely. A data scientist is, a data engineer is another role, and that's quite different than the data scientist I'm describing. At Google, that data engineer would be a software engineer who's specializing in data engineering. And then there's the machine learning engineer, which is another specialization at Google for software engineering. You know, data scientists work with machine learning systems at Google. They work with machine learning systems. They are often part of teams that build them. But a lot of the machine learning systems at Google are very large scale. And it's kind of like, we're at the age where in order to drive a car, you also have to be a mechanic because, a lot is involved in getting the car on the road, so to speak. So in that sense, a machine learning engineer has a lot of engineering skills that we don't expect from our data scientists just to make that machine learning system work. That said, data scientists are very often involved in analyzing these systems. Okay. So I just wanted to, there's no requirement here, but I just wanted to mention that data scientists, a stats PhD, for example, would often be joining us at Google as a data scientist. Okay. So how does being a statistician help? You guys are statisticians, getting a degree, as far as I understand. So how does that help if you're going to be a data scientist? And the first point I'd say is variance. Why do I say variance? Because, I like to say that smart people, that is to say software engineers, can figure out how to deal with the mean of something. But it's variance that screws them up, right? And statisticians are trained to think about variance. Variance comes in the form of uncertainty when you're measuring something. Variance comes in the form of regression to the mean, for example, just all sorts of places, right? So that's our specialty if we study statistics, and data scientists, as a data scientist, you'd practice that. Statistical uncertainty in all its forms is there, bias, variance, trade-off, what have you, all of that you study as a statistician. That's very useful. Another point I'd like to make is that it's a little bit different, but oftentimes you talk to smart people and they have some idea, but they don't formalize their assumptions clearly. And so it's hard to understand what is being assumed and what are the implications of those assumptions. Well, as a statistician, as any mathematician, I guess anybody with mathematical background, you'll have some practice formalizing the assumptions. So you can clearly state, okay, based on these assumptions, this is going to happen, right? And so that really helps understand what we're building sometimes. Related to that is the notion of estimator estimand. If you read, you guys have probably all read Fisher's work from the 20s, where he says, there are many ways to estimate something. That thing that we're trying to estimate is different from the ways in which we are estimating them. Now, this estimator estimand distinction I see a lot of the value that data scientists bring, because oftentimes if you talk to a smart engineer or research scientist who doesn't have training in this place, they kind of conflate the thing they're measuring with how they're measuring it. So that's, it's like the interface versus an implementation, that kind of distinction that comes from statistics. So it's very valuable. Obviously, there's hypothesis testing that you guys learn about and statistical significance. I don't know how many of you study experiment design. I never studied it in graduate school, but it's super valuable if you do. Experiment design, statistical power. Causal inference is another big thing. And, I went to college more than 20 years ago, so it's different. But since then, causal inference, especially causal inference without randomization, without complete randomization, is something that's a growing area of interest and something that you can bring to the table. It's very valuable if you have those skills. And then, of course, modeling, regression, all that stuff. Okay. So now, James had asked me to talk about some of the gaps that might occur between a trained statistician and this data scientist role. So let's see if I can communicate this properly. So there's sometimes an over-reliance on mathematical assumptions. I'll give you an example. This is from a colleague of mine who was interviewing some candidate, and it was a question, I think, about the probability of raining on a given day in a week, right, in a particular week. And that person said, well, let me assume that, rainfall on any given day is independent of every other day. And my colleague said, well, is that a good assumption? I said, well, that's my assumption, so I'm proceeding from there. And as a mathematician, that's fine, because you make your assumptions and you build your world, and then you show people what is implied by those assumptions. But we live in the real world, and data scientists as data scientists, if that assumption doesn't make sense for our world, we have to change the assumptions. And so assuming independence of rainfall across days is probably a poor idea. So we have to, so that's where you can't protect yourself by making strong assumptions. The assumptions have to match the world we live in, and that's a gap. And this sometimes bothers mathematicians who yearn for completeness and clarity. And in the real world, that can be a little bit hard. Another part of that is, when you're living in the real world, the data is messy, the data is problematic. You probably heard that many times. But making meaning from the data is a big part of the job, which is to say, you never have exactly the data you want. It might be indirect measure of something. And you have to figure out to what extent am I allowed to make it mean, to make it mean what I want it to mean, right? How much can I trust it? How far can I push it? Those are the kind of questions that a statistics degree, I don't believe, typically prepares us for. Now, social scientists sometimes do get that, like in psychology or sociology. Their facts are a little bit more debatable. And so this is the world we live in, where the measures aren't quite what you would hope to make, but you still have to make progress. In general, there's going to be ambiguity in whatever we do. It's real world ambiguity. And it's sometimes the ambiguity of the question, sometimes it's the ambiguity of the data. There's a lot of ambiguity, and you have to sort of learn to live with that. And again, if you have a very precise, pristine mathematical mind, this might be bothersome. So that's another thing to think about. Now, practical significance, you've all heard, I'm sure, about statistical significance versus practical significance. But how do you know what's practically significant? You kind of have to understand the goals and purposes of the organization. Otherwise, you can't really say if it's practically significant. Let's say a 2% rise in blood pressure across California. Does that matter? I don't know. I mean, I guess it sounds big, but it depends on factors that I'm not aware of. And if I had more context, I could decide if that was practically significant. Okay. The ability to communicate with non-statisticians is another thing that you probably don't acquire when you study statistics and you're going through a statistical program, because most other people around you are statisticians. That's something that's really valuable and important because a lot of the people, a lot of the stakeholders are not statisticians. So you have to learn to be very precise in your own mind. Oftentimes, I like to write a statistics-oriented document, but then I like to write a version of it that's for non-statisticians, just because it allows me to be honest and clear to myself and to other statisticians, but then at the same time communicate with somebody who isn't going to be able to understand all those specific terminologies. Now here's this quote, so what? So I have a colleague who recently retired, Mike Meyer. He's famous at Google for asking the question, so what? And what I mean by that is, if you look at data is often very rich, and you can find lots of interesting and statistically significant things about the data. The question is, why should we care, right? And because there's so many facts defined in data that you have to always be able to answer the question, okay, you've told me this, but so what? What next? What's implied by that? That's again relating it to, relating your findings to the purpose of the organization. And finally, many statisticians probably don't get a lot of programming practice and training. That's important to have. I guess maybe these days people do, but in my time, certainly many didn't. Okay, so a few more. So I'm going to restate in a different form pieces of what I said, right? So as a statistician, you're prepared to deal with statistical forms of uncertainty. That these are the uncertainty, types of uncertainty that come from problems of measurement. So what are appropriate bounds on this estimand? Given my estimator, what can I say? All right, but there are other forms that you are perhaps less well prepared for. Here we go. So these are the things I'm highlighting. So what I'm calling representational uncertainty, I don't know if these terms will stick, but I hope. And that's the idea that you're trying to make meaning from data, right? So to what extent can the data mean what I want it to mean? That's not really a statistical question. That's a question of inference, but it's a lot of logical inference from the data and from the provenance of the data, all of that. And the final point is what I'm calling interventional uncertainty, which is that, how do I evaluate an intervention? So my organization is going to do things. My business is going to launch a product, make a change, give people discounts, whatever it's going to do. It's going to do something. It's trying to figure out, should it do that? And my job is to help with the decision making. So evaluating what is the likely impact of the action is kind of a big thing that data scientists have to do. And there's a statistical question there, but there's also this counterfactual question. What if we didn't do it versus what if we did do it? How do we figure out the delta? And the net set of implications, the ramifications go on infinitely, or could. So how do I bound this in some reasonable and meaningful way? Again, it's not, there's statistics in there, but it's not entirely a statistical question. Okay, so I'm coming to the end of my presentation. Just want to give you some pointers on what kind of skills do you need to get hired. Okay, so obviously you should know statistical fundamentals. You know that if you're a statistician studying to be a statistician. But critical thinking with data, that's something that we really care about. Because that's where the meaning making comes in and stuff like that. You have to be able to make progress despite ambiguity. You should have strong communication skills. Now here, one of the biggest points I can make for you today is that think of communication as a two-way skill. It's not simply you saying stuff. It's also you listening to see if they understood. Or if they ask you a question, you might follow up with a clarification question rather than just going on autopilot. So that's kind of a valuable thing to keep in mind, not just at Google, but any interviews you do. I would say, please think of the two-way nature of communication. Having solid programming skills, not necessarily to build infrastructure, software infrastructure, but to be able to do analysis, especially at scale. And then your particular expertise is always going to be valued. Today, there are two other companies speaking. They're also large companies. So large companies have the possibility of really using your specialized skill very broadly. And so whatever your specialized skill is, that's going to be a reason that people want to hire you. Okay, how to prepare? Certainly review your stats fundamentals, review your stats programming skills, practice finding insights from data, right? Like from real data, try to see if you can make inferences from that and learn to be able to communicate that to somebody else. Another little pointer, again, it's a really practical thing. In an interview, when you're solving a problem, it's useful to sort of describe your thinking while you're doing it. You don't have to say everything, but it's useful to keep the interviewer somewhat plugged in, because they can, if you're going in a different direction, they can sort of give you feedback and say, hey, maybe you should think of it this way, whatever. If you're just completely silent until you have the answer, then that's probably not as good. This is pure interviewing skill. Won't be very useful once you're at Google, but I think this is kind of just a little tip here. And finally, practice communicating complex ideas such as your thesis or other projects to somebody who isn't you, and for whom you can highlight the main points. Okay, so how do you apply? If you know somebody at Google, as you probably do, then certainly ask them to refer you. That helps just sort of track your case. But otherwise, you could just go directly to careers at Google. Careers.google.com, and then if you just type in data scientist, I just said yesterday and I saw 125 jobs, so lots to do there. Thank you so much, and have a great career as a data scientist.
Thank you, Amir. Many questions have come in. Can we take two for now, specifically towards Google?
Absolutely.
Yeah, the first one, would software engineers have a preference to be hired in data science over statisticians?
Oh, you're saying, okay, if I
Is there a
understand.
preference for software engineers versus statisticians?
Okay, so I think it means that if you have been trained as a software engineer, are you more likely to be hired into a data scientist role than if you were a statistician? Um,
Yes.
I don't think so. Not at Google. I mean, it could be true of other data scientist positions in the industry, but for us, I think you're more likely. Now, if you have no programming, I mean, I don't know how in 2021 you can get through a college degree without knowing any programming if you're doing statistics, but I don't think it's true. I think statistician is probably much more likely to get accepted into the role.
Thank you. Next one. Are there activities happening at Google and Google Alphabet regarding health and wellness? You recently purchased Fitbit, so what are some of the jobs we could look into for our skill sets in biostatistics? So if you're a biostatistician, what are the opportunities in Google? I guess, yeah.
Gotcha. So yeah, so unfortunately, Google's a big company, and I can't really represent everything that they have going. But I do know Fitbit is hiring. So, and the reason I know is because I went to careers yesterday, and when I did the data scientist search, I saw that Fitbit's actually hiring people. So there's that. I don't know how big health is at Google in terms of for data scientists. I don't think. Well, so there is a health group. I know there's a health data science team that's working on various things, such as, for example, you may have seen stuff around COVID, and it's more like public health things, I guess. There's also a lot of, in search, a fairly large fraction of queries are about health. So, there's that aspect too. But yeah, Fitbit is definitely hiring. I'm sure of that because I saw. I'm sorry I can't give you a better answer because I'm not as knowledgeable about everything, but there's certainly going to be some stuff.
Thank you, Amir. For the interest for time, let's move on to our second panelist. Amir, if you could stop sharing and Martin can share his slides.
Thank
Our
you.
second panelist is Dr. Martin Tinley. He leads a multidisciplinary team on the Netflix experimentation platform, focused on developing and scaling both statistical methodology and software solutions to improve decision-making across the company. Prior to joining Netflix in 2017, Martin spent several years modeling and pricing catastrophic risk at Insurance Australia Group. In the earlier academic career, Martin was an assistant professor in statistics and meteorology at Penn State University. Martin holds a PhD in Earth and planetary sciences, an MA in statistics from Harvard University, and a BS in physics from the University of Toronto. Martin, please.
All right, thank you. And thank you, Amir, for everything you said. Almost all of that is very much applicable at Netflix. So I'm happy I went in a very different direction with what I'll talk about today. This is going to be a lot more personal. And it really comes out of the question that I get asked more times a month than I can count, which is how did I end up at Netflix and what did I learn along the way? So as mentioned in the intro, like my academic background is this interesting mix of Earth and planetary science and statistics. And when I look back at my life, picking up that master's in statistics was probably one of like the top 3 best decisions I have ever made. And when I graduated back in 2009, I was basically 100% on the faculty path. I was pursuing interdisciplinary research at the boundary of applied statistics and climatology, working with interdisciplinary teams, having a great time. So what happened between then and me leading a software/data science team at Netflix? Well, let's go through a bit of history. Yeah, so a bit about my research then. I was looking at a lot of data to do with climate and weather, from things as varied as old temperature gauges to ice cores from Antarctica, and using statistical techniques like quantile regression, space-time analysis, hierarchical Bayes, to really bring more of a fundamentally like modern statistical approach to addressing all of these open questions in climatology and climate change. It was a great deal of fun. So after graduating, I spent a year right next door to NIST at SAMSI. And I did this to try to like up my credibility as a statistician by spending more time with the real statistics community. And I think that was a successful decision. that point in my career, still basically 100% on that faculty path. I then spent a year out in Colorado at NCAR working for a now defunct research group called IMAGE, the Institute for Mathematics Applied to Geoscience. I always felt like this was my spiritual home as an academic. Continuing along that research, interdisciplinary research in statistical climatology. But at this point in my career, some doubts started to creep into my mind, like, what am I? Am I a statistician? I don't know. Am I a climate scientist? I'm not sure I know enough about how the planet works to justify saying that. When I look back at my career so far, the time in Colorado, definitely best office award, without a doubt. Right up in the tower, looking due west into the Colorado Rocky Mountains. It was awesome. I then went back to Harvard for a few years as a postdoc, super postdoc, research scientist, whatever you want to call it. Got exposed more to working directly with grad students. The faculty advisor I had at the time was on sabbatical, so I was de facto supervising some of his students, writing a lot of grant proposals, enjoying the unique joy of being rejected by the NSF. And I started to have real struggles on the academic job market, as well as struggles with funding, but it was a super productive time for me. Tons of papers, tons of collaborations. And my dedication to that faculty path started to sort of drop down a little bit. One of the questions I started asking myself is, maybe interdisciplinary research has its drawbacks because it's very easy for a department to say, well, that other department should hire you, or for the NSF to say, well, that other part of our agency should fund your project. Then in 2013, I did in fact land a tenure track faculty position at Penn State, a joint appointment in statistics and meteorology. It's how I know Jim Rosenberger. And in many ways, this is an ideal outcome on that academic path for me. Penn State was hiring applied statisticians who could sit both in the stats department as well as a domain science or social science department. So a great opportunity for me. But sometimes, you finally get what you want and realize it's not quite what you want after all. And when I look back at this, I thoroughly enjoyed every individual element of being a faculty member. I loved the teaching, I loved the research, but for me, ultimately, the package wasn't quite there. My wife at that time was still based in Boston, so it was a lot of driving. I was still struggling with funding, but I was also super productive. One of the pieces of advice a lot of new faculty get is learn how to say no. So being an iconoclast, I said yes to everything for a year and was super overcommitted, but had a great deal of fun. But a lot of nearly existential questions came up with both myself and my family, including do we want to live in this community in central Pennsylvania? Is this the life for me? I like all the components, but does the package make it worthwhile? And when you think about an optimization problem, if local exploration of the parameter space is not really getting you to that optimal solution, one approach is to sort of blow up the problem and jump to a totally new area of the parameter space to see if you can't kind of optimize what you're trying to do there. And that's what my wife and I decided to do. We moved to Australia, and I transferred from that academic path to the private sector, working, as just mentioned in the intro, for an Australian insurance company. What I did in that role was I priced natural hazard risk like cyclones in Northern Australia. I also spent a lot of time working on the settlement for a series of earthquakes that hit New Zealand in 2010 and 2011, which is widely viewed as the most complex insurance settlement in human history. So it's a very smooth transition to the private sector for me because I was still dealing with weather, climate, earth type data, still doing probabilistic analysis. Now we were just adding dollar signs at the end and calling it premium, calling it risk. And this is a great opportunity for me to learn more about business, to learn more about global risk management, new ways to frame problems, new metrics for success. But I do want to emphasize, and this is something I learned too late in my career, the academy has no monopoly on interesting people and problems. And it was kind of an eye-opener for me to realize, wow, this is some crazy large insurance company. But if you poke around, there's some amazing people and some amazing opportunities and challenges. This gets the Best Place to Live award. I lived literally 400 meters from the beach in Sydney. It was fantastic. But life has a way of throwing curveballs. So in 2017, I got an email from a Netflix recruiter. And before you know it, we were flying back across the Pacific. And for the last close to 5 years now, I've been leading data science teams at Netflix with a large focus on experimentation. And I'll talk a little bit about that in a minute. Without a doubt, this is the Best Job Award. I will never have a job as challenging and satisfying as what I found at Netflix. So massive personal growth for me, new challenges, and amazing colleagues to learn from. So what do I do at Netflix? What does my team do? Well, I've linked here to our research website and our tech blog. We've actually been putting out a lot of information about what we do. I've been encouraging us to share more externally, in part because whenever Netflix shows up at JSM, we are asked, what is Netflix doing at a statistics conference? And I am determined to eliminate that thinking through sharing more information about what we do. Okay, so I work on our experimentation platform, and I lead this interdisciplinary team of software engineers, and we call them data scientists, but really they are applied statisticians. And to give you a sense about why this team exists and what we do, I like to start with this image. This some of you might recognize. It is Rothamsted Research Station, where R.A. Fisher worked for about 15 years. And that's where he developed much of the inference procedures on randomized controlled trials that are still widely used today. But the image in what I showed you, it gives you a sense of the scale and throughput of the experiments they were running back 100 years ago, right? You can only divide the chunk of land into so many plots. Plants take a long time to grow. So the data volume and throughput of experiments is relatively low. So fast forward to what we do at Netflix. It's fair to say that absolutely everything you experience on Netflix is the winner of some type of randomized controlled trial that Fisher himself would have recognized. We run experiments to optimize the UI so folks can find the content they're looking for. We run experiments to optimize the backend recommendation algorithms. We run experiments to optimize how we use AWS infrastructure. Like if we can figure out how to run an experiment to inform a better decision, we will do it. And the scale of the data compared to what Fisher would recognize is insane. And Netflix is small compared to Google and Meta in that regard. We have over 200 million subscribers. We run hundreds, if not thousands, of experiments simultaneously. So there is this real emphasis on data scale and throughput. So when I think about what I find interesting about my position and team, sort of three things. Well, we run randomized controlled trials that Fisher would recognize. We aim, as Amir talked about quite a bit, to evolve our products and make decisions based on data. So this is ingrained to Netflix culture. It's sort of the de facto norm at most big tech companies right now. And I think what makes my job most interesting is that we're trying to build engineering systems to support scale and research agility. And I think this is the really hard part and what I found really gratifying over the last couple of years. In effect, we're trying to bring the power and scalability of software systems to data scientists without turning data scientists into software engineers. So to really drum it down to a very simple message, the goal of my team is to make established statistics extremely fast and extremely accessible, even to those who don't have that training in statistics. So we aim to turn innovation into commodity. So whatever our data scientists are doing this year that's super interesting, next year, somebody who's not a statistician can click a button and get those results and interpret them as well and make safe decisions. So this is a poster we presented at a conference last year. We talk a lot in my team about democratization. We want folks to be able to push methodology onto our platform. We want our platform to be able to support a wide variety of users who are running experiments, both those who have a lot of formal statistics training and those who don't. Okay, and there's a lot of other uses of statistics at Netflix, from traditional business informatics analytics to the type of product manager partnership that Amir talked about. The one I'd flag here is that stuff at the intersection of machine learning and causal inference is very hot right now. So I want to take about 5 minutes here before I wrap up to talk about some personal observations. And I seem for some reason to spend a huge amount of time providing mentoring and having career combos with different people. Basically, I'm a sucker if you email me, and I'll generally be willing to talk to folks. And so here are a few of the themes that I've seen emerge again and again. I want to note, like, everyone's journey is different. This is some stuff that's worked for me. You know, your mileage may vary. So first off, you might think your future looks like this. It probably doesn't. It probably looks more like Odysseus setting out from Troy to go back to Ithaca. Future is uncertain, and when I look back, it's taken me an awfully long time to get where I am, which is like this fancy job at a super fancy technology company. But what I want to stress is the steps I've taken along the way have been enormously beneficial to me. I'm better at my job for having had this kind of meandering career where I've picked up different skills, both technical skills and non-technical skills. Slow route has its advantages, even though it can be really frustrating. So if your path seems more meandering than you might have expected, I think that's okay. There's more than one way to get to where you think you want to go. My own path has been a lot different than what I would have told you it was going to be back in 2009. And at times, I've clearly not had any idea where I'm going. I think that's okay, provided you view every stop along the way as a learning opportunity. The other thing I've come to appreciate is that, you know, after you make big decisions, like, should I take this tenure track position or should I go work with Amir at Google? Like, commit hard to the decision, right? Don't second guess yourself. Focus on the future and focus on learning about how you make decisions. So that next decision point in your life, you can do a really great job of assessing the opportunities. And last here, you know, I really believe that the goal is not to get from the mountain to the sea as quickly as possible. I found enormous value in exploring and being open to opportunities that are way off the path I've envisioned for myself. I take a lot of calls from recruiters from pretty random companies just to understand, you know, hey, what's going on in your space? How interesting is that? You know, might I find satisfaction and value in that? Just gather more data and actively challenge my own assumptions. Because as I said earlier, there's great people and there's great problems everywhere. And I've really enjoyed learning about those. A lot of what I've just said is in this book called Range that I recommend to everyone, Why Generalists Triumph in a Specialized World. It was very eye-opening for me. Perhaps other folks will find some value in it as well. Okay, now I'm going to end with something super spicy that might annoy folks like Jim Rosenberger, but that's all right. So one question I get asked a lot is how to successfully transition from an academic career to a private sector career. And this is like a more abstract version of a lot of what Amir talked about. I think it's important to acknowledge a core fundamental truth. Your graduate education has probably not prepared you well for the real world. Straight up, I'm going to assert that. Now I'm going to unpack that a little bit. When I think about what graduate education provides folks with, including myself, it gives you a toolkit of technical and non-technical skills, right? In my case, that was really the toolkit of applied statistics. And then graduate education teaches you to use that particular toolkit to optimize a particular utility function. Here, this is the quadratic utility function standing in for the academic career path. But what I want folks to realize is that these can be decoupled, right? You have a skill set, and then you've learned to use that skill set to optimize a particular utility function. And these are not tied together. So depending on what career path you choose, the utility function might change. Here we've got OLS as well as some, you know, tilted absolute loss functions from quantile regression. And what I want to emphasize is that if you use your existing toolkit and then make the wrong assumption about the utility function you're trying to optimize, things will go very poorly. However, if you recognize that like the toolkit of modern applied statistics plus a bit of computer programming is basically the most portable skill set on the planet, and then you consciously and deliberately try to understand the utility function that you might face in a new career, you can be very successful. But failing to make that conscious recognition that the utility function has changed will not go well. So as a very specific example, in many industry positions, there's almost zero value placed on novelty, right? When I think about Netflix, we'll run t-tests if they work, right? So there is, however, enormous value in understanding when it's safe to use simple tools, educating folks about when it's safe to use those simple tools, and then making those simple tools accessible to a broad variety of people. So in that context, focusing on that old academic utility function will not go well, but your skill set can be adapted to that new scenario you find yourself in. Okay, that's it from me. Thank you for listening.
Thank you, Martin. A specific question for you, Netflix. Creating a culture around experimentation can be difficult when you have business stakeholders asking why on earth they would withhold half of users, clients, customers from their program for the sake of being more certain it's helping. Have you encountered similar pushbacks, and how do you tackle it?
That's a great question. So we're in the middle of putting out a pretty lengthy series of blog posts about experimentation at Netflix, and the last entry in that series will get at that question. Netflix is lucky in this regard. From the executives on down throughout the company's history, it has been made clear to everyone that we will use data to make decisions. We will use experiments to make decisions. So when we hire product managers, even, we hire folks who are aware and bought into the notion that if you don't have experimental data to back up your decision, that's just not going to go well. Other places, I think that is more of a legitimate challenge, and building that culture of experimentation is kind of an exciting opportunity for those who might be interested in it.
All right, our last panelist today, Dr. Elliot Merriam. He holds a PhD in neuroscience at the University of Wisconsin-Madison in the lab of Dr. Doug Dent, where he studied the effect of neuroactivity and synaptic communication on molecular dynamics involving brain cells using real-time fluorescein microscopy. I'm sure if you ask him about his research, he'd be very happy to talk about them. After the PhD, Elliot was a senior fellow at the University of Washington in the lab of Dr. Larry Ziffel, where he studied the neural circuitry underlying motivated behaviors in mice. Following his postdoctoral fellowship and before transitioning into data science, Elliot joined the patent practice of law firm Wilson, Sonsini, Goodrich, and Rosati, where he worked on patent applications and litigation matters. To pursue a career in data science, Elliot accepted a fellowship in the Inside Data Science program, which led to a role as a data scientist for iSpot TV, a television advertising analytics company. After iSpot, Elliot joined Facebook, now recently renamed as Meta, where he has worked as a data scientist on integrity and security problems for the past 4 years. Elliot, please.
Okay. Thank you for that. So yes, I will present a fairly short and sweet slide deck, which hopefully will leave more time for questions from our audience. I will discuss infrastructure data science at the company formerly known as Facebook, recently name changed to Meta. I'm still trying to get used to it myself. I'm a research data scientist at Meta, and I'll talk about infrastructure data science. So as I said, these will be fairly short to the point slides. I just want to go over kind of a high level of what we do within the company and how we work and who we are in terms of our background and skill set. And also, of course, to make you all familiar with opportunities at Meta. Okay, so what do we do? The infrastructure data science and data engineering org in Meta partners with infrastructure teams, not surprisingly, to develop data-driven solutions for a large number of different infrastructure challenges. So just to give a little context here, that's not actually on the slide. There's actually 3 different data science orgs at Meta. There's an infrastructure data science org, and a product analytics data science org, and a core data science org. So the product analytics data scientists are a bit like the sort of product analyst or business analyst role that Amir described in Google. I'm not saying they're exactly the same, but I think they're probably filling a similar role. Infrastructure data science, which I'll talk about more, is heavily related to infrastructure problems within the company, broadly construed. And then core data science, and we work in an embedded capacity, which I'll talk more about. And then the core data science is actually kind of a siloed team of data scientists who work mostly with each other and build data science products that are exported to the company at large. So yeah, that's just to set the context. I will talk primarily about infrastructure data science. Okay, so what do we do in infrastructure data science? We work on problems of scalability, efficiency, reliability, measurability, and most recently, privacy. So this is kind of not limiting, but these are kind of high-level themes that we focus on. So scalability refers to ensuring that we meet demand and that we're able to forecast both long-term trends in demand as well as short-term spikes. And by demand, I mean demands to our network infrastructure. We work on efficiency, which means that we look to save resources and save energy and save person hours of work in our systems. We want to have reliability. For example, new versions of the app are continuously released. And we want to make sure that if there are problems with reliability, we detect them quickly and respond. Measurability, I think, probably at most organizations is a pretty big component of data science. We want to, Facebook is a Meta is a metrics-driven organization, and we want to have metrics that help us to set goals and communicate how we're doing across all aspects of the business. So infrastructure is no exception. And then privacy is actually the area that I work in. We want to honor people's privacy by limiting data use and building protections against data misuse across all of our products. Okay, so how we work. This is we are using an embedded or matrixed structure, which is a lingo in industry, which basically means that we are actually embedded in a team, in a multidisciplinary teams that involve engineers, product managers, data scientists, and other folks to either focus on a product or a problem. And we want to establish the product requirements, gather data, design experiments, create models, and build tools and communicate findings. I think a lot of this overlaps with some of what Amir described. It's oftentimes a role where the data scientist needs to basically be the voice of kind of what is true, what do we know, what do we not know, and be able to communicate that effectively across product people and engineering people so that everybody is making informed decisions. That being said, we do kind of look for sort of full stack data scientists, and I'll talk more about what that means in subsequent slides. But the culture of Meta is definitely very impact focused. So ultimately, you may use very fancy, complicated machine learning or statistical tools, or you may implement something very simple, or you may actually put on more of an engineering hat just to ship something. And the kind of bottom line is whether or not you solved the problem, made forward progress, and had impact. Okay, so with respect to who we are and what kind of folks we look for to join, it's actually a pretty wide range of backgrounds. I think there were questions from the audience about, do you favor people with an software engineering background or computer science background versus statistics? And the truth is, I think for us at least, there's no such preference. There is a set of core competencies that we kind of need people to have, and I'll speak to those here and in the next slide, I think. But it doesn't really matter how you got there, right? Like you may have a background in statistics and depth of knowledge in statistics or math or computer science, or you may come from physical sciences or biological sciences, economics, psychology. I would say these are broadly speaking technical fields, and most of our candidates have some kind of technical background, but it varies a lot. And I think there are many ways to achieve the core competencies that we need people to have. And those core competencies are really statistics and ML, coding skills, problem solving, quantitative problem solving, and sort of soft skills like your ability to collaborate effectively and communicate effectively. I'll get into more details of these. So very specifically, because I know folks are probably thinking a lot about, kind of how to make this jump, right? This is kind of like the the crib sheet of the slide deck. These are the kind of core technical skills that we're looking for at Meta for infra data scientists. There's data manipulation, coding, and stats ML. Data manipulation typically means SQL, but we're actually language agnostic. It would be completely fine to demonstrate these skills in something like the Python Pandas toolkit or in R. The core concepts are, just putting data sets together with joins in an appropriate way, aggregating data sets. This is kind of not the most intellectually stimulating aspect of data science, I would say, but it's sort of the nuts and bolts toolkit that you're going to use all the time to be able to move data around and just organize it to do more interesting things with it. And then our coding, I think, maybe one thing that differentiates our this particular role from others in across the industry is that we are looking for more of a generalist who can do a decent amount of coding. They don't have to be at the bar of a software engineer. The software engineer bar is definitely higher in terms of coding, but there is a coding component to our interview process that involves, demonstrating understanding of data structures and algorithms and time and space complexity. These are concepts that if you have a computer science background, you're going to be very, very familiar with. But if you don't have a computer science background, you kind of need to gain that familiarity. It's doable. It's not something you can necessarily learn in a month, right? It will take a more deliberate process, I think, to get up to speed. And so this is something that I want to stress to this audience, because I think probably it's a lot of people with really, really strong quantitative and statistical background, but maybe, maybe your coding has just been in the service of analyzing data and you haven't done these kind of pure computer science types of problems. They do come up in industry. They are expected for some roles, including the infrastructure data science role at Meta. So I encourage you to brush up on this and to give yourself some time to prepare for this component of the interview, if it is a component of the data science role that you happen to be kind of targeting yourself towards, which is a big if, and that's something we can talk about. But you want to understand the role that you're going for and what the expectations are. But if this is one of the expectations, don't feel that you need to have a computer science degree to have a chance of achieving it, but also don't, my advice to you would be also don't make the mistake of thinking that you can learn this stuff in a month. You'll want to give yourself a runway to build up these skills. Okay, that's my little helpful advice for everybody who's interested. And then the stats ML component, which is probably where many of you feel probably the most comfortable. Some sort of core bread and butter statistical things like hypothesis testing, probability. I would say that for this particular role, we are looking more for generalists. And so, most people in this audience are going to be vastly overqualified in a sense. You probably won't have too much trouble with those kinds of problems. But there is sort of a bar there. We expect people to understand, how to interpret and implement an A/B test, for example, and basic probability. With respect to machine learning, understanding kind of fundamentals of supervised learning, and by that I would include both regression and classification, understanding concepts like regularization, goodness of fit, understanding precision and recall, evaluation of model, overfitting, underfitting, that sort of stuff. And then as well as unsupervised learning, methods such as clustering and dimensionality reduction. I think it's again, we're not looking for a PhD in machine learning for this role, but we are looking for sufficient depth of understanding that you could implement some of these models and demonstrate ability to implement these models in Python or R, for example. Okay, I think one thing that's probably very underappreciated is the importance of soft skills. It is really, really difficult to be successful in industry, in my experience, no matter how technically competent you may be, if you're not able to communicate and partner with people effectively. This puts a really, really low ceiling on how far you can get. You may get a data science job, especially, but it's particularly if it's a larger organization, but I think really even for any size organization, there will be a limit on how far you can go within your role and growing your career if you're not good at communicating and partnering with folks. So I think this doesn't mean that you have to be the most eloquent speaker in the world. It just means you have to be good at explaining what you're trying to say to folks so that they understand what you're saying. And I think being able to partner with people, which a lot of it is just, kind of the things we learned in kindergarten, right? Like treat people with respect, listen to what people are saying, recognize that people may have a difference of opinion and that other people's views need to be respected. These are actually really, really important when you have different stakeholders with different competing views. And, I thought about this when Amir was talking about the role of the data scientist at Google. It's like, if your job is basically to be impartial, then you're going to have to talk to a lot of people who probably have a very strong opinion that they think something should or shouldn't ship. And you may be telling them things that they don't want to hear. But if you do it respectfully and you're in an organization that respects, data and evidence, that can be done in an effective way. But it's really important to be kind of to build up that muscle of communication. And this is definitely something that's, I think, most companies look for in the interview process, in addition to technical ability, is just how confident are we that this person can kind of state their position clearly or communicate their findings clearly, and then sort of respectfully, but also confidently hold their position, and not sort of be bent by people who may have an agenda or who may want to push them one way or the other away from what evidence shows. Okay, and I think also in Meta, there's a lot of emphasis on kind of the ability to influence the broader vision with data and insights. So it's not just, okay, please tell me what is the answer to our question, and you're a data scientist, so go give us the answer and come back. Rather, and give us the answer and then leave. Rather, it's that we should be using data to kind of make the case for what is the right thing to do. Maybe this differs actually a little bit from Google and other companies. I'm not sure, but I think at Meta we definitely use data, insights, and findings to kind of support a position and persuade our partners to actually adopt that position and make decisions accordingly. Okay, enough about that. So yeah, as I said, we were obviously hiring. I apologize. I think the links that I put in the slide deck a few weeks ago may now be dead, but they will at least direct you to our hiring portal. And I think if you search for data scientist roles, the research data scientist role is the one that I've been describing. Or if there are folks here who will not be graduating before 2023, I would suggest that you look for the research data scientist intern opportunities. And I think that's all I have, so we can take questions.
Thank you very much, Elliot. So now I think it is a good time for us to open up the floor for questions. Our attendees are very active today, and I think the questions actually coming in themes. So one of the very common things here is that how does your company value previous experience? There are several types. No experience owning business, but doing a technical degree, say informatics, hoping to transition to breaking into high-tech industry, for example. And another type is research and scientists with no working experience, very interested in one of the high-tech companies.
I can respond to this from the Netflix perspective, but I do want to highlight that Netflix is a pretty particular recruiting strategy that does differ substantially from Google and Meta. So for most of our data science roles at Netflix, we are looking for folks who have advanced degrees as well as private sector experience. That said, for the right candidate, we break that principle quite frequently. But because as a company we are actually much smaller than Meta and probably an order of magnitude smaller than Google, we are a little bit more selective in how we hire and don't really have, say, big boot camp programs for new PhD grads.
I can say that we hire plenty of people who are fresh out of college, with a PhD. I mean, it's a pretty well trodden path, right? That said, we certainly hire people with experience also, and you could have a more advanced, come in at a higher level if you have work experience as well.
Yes, pretty similar to Amir's answer. We hire people fresh out of college or grad school. We hire people with industry experience. We hire people who maybe are academics who are in a postdoc, so they have post-grad experience but not in industry. These are all applicants that we're interested in. The only caveat being, as I said, I think if you're going to graduate after 2023, then what you would want to do is pursue the data scientist internship, which is a paid internship, and that would be the way to work your way towards a full-time opportunity.
Great. A question asks, when they hire statisticians, how important their research area, for example, dissertation is. Also, how do you evaluate soft skills of the candidates?
So I guess I can give this a try. This PhD. So whenever I'm interviewing, and I still do interviews quite a bit after 16 years of being at Google, still have to do interviews. It's probably the best part of my interview with somebody, for me personally, is to ask them about their research. One, it allows me to learn something because I graduated from college more than 20 years ago. So that's valuable. Also, it allows me to tap into their passion. If they spend a serious amount of time doing something, I want to know why they cared about it. Now, if it was because the advisor assigned me this project, I mean, that's probably not such a great conversation there, right? So passion is great. Some of the soft skills do come out there because they're the expert on something. I'm not the expert usually on their subject. So they have to explain something to me. I'm not going to be the smartest person they're ever going to talk to, but I'm probably not the dumbest either. If they can't explain to me, then that's a problem, right? So it's a way to get some soft skills there. In general, I think it's hard to sort of get a sense of soft skills. But the thing I told you, the tip, my strongest tip, if I had known this myself years ago, I would have used it. But it's to think of the communication as a two-way street. I think typically when you're sort of early on in your career, you go to an interview, you think, okay, you're there to be examined by the other person, which is of course true, but you have a lot of agency, and exercising some of that agency will be to your advantage and show yourself.
Yeah, I'll follow up on that. The communication thing is so key. Like, one of the pieces of advice I give is think less about how much you can communicate in 10 minutes and think more about how much your audience can understand in 10 minutes. And your audience throughout an interview loop will continuously change. So when I think about assessing those soft skills in an interview loop, it's something that's assessed throughout. Every contact you have with a recruiter, with one of your interviewers, is an opportunity for you to show up, be curious, be open-minded, be quietly confident, but also really humble, and view that as a learning experience. In terms of specifics versus general skill sets coming out of a PhD, I think it depends. There are times when you'll find like, hey, I have a PhD where my research focused on like experimentation on network structures, and LinkedIn has a job posted where they want to do exactly that, and it's a great fit. But the other thing a PhD shows that you can do is it shows you can complete a PhD, which involves a lot of coursework, a lot of communication, a lot of self-directed work. It involves delivering on a very large piece of work over a number of years. So again, from that lens of a portable skill set, that PhD demonstrates a level of success across a broad variety of dimensions that are important both within the academic sector and outside.
Yeah, I would plus one both what Amir and Martin said. I will say that I think, at least in our process, there are interviews for roles that are kind of what we call pre-allocated, which means we've already decided like what team and what problem this person will be allocated to. But that's kind of the less frequent case. The more frequent case is that we're hiring a person to be a data scientist at Meta. And which team they will join is sort of TBD in the future after we've made kind of the decision about whether or not it's a good fit for the company. And so for that first initial stage of getting the job, it's not really the case that what you did in your PhD matters, right? Because it's a standardized process, right? So you kind of either pass these interview loops or you don't. That being said, I think I would agree that, right, like if you speak to your academic experience, you know, in an engaging way and show a lot of passion and enthusiasm for specific problems, that reflects really, really well, right? And to the question of soft skills, there is actually a loop that basically, you know, sorry, loop is jargon. There is a part of the interview process where we will, you know, kind of walk through scenarios, past experiences or hypothetical scenarios, and just get a sense for how you would handle different situations in terms of like interacting with partners, maybe difficult situations, that sort of thing. That is sort of a soft skills interview. But even for just like a coding interview or any other part of the interview process, everybody obviously can kind of get a sense of how you interact, how you communicate. I want to really signal boost something Amir said earlier about interviewing, which is that you should tell the interviewer what your thought process is and what you're trying to get to. Don't just turn with your back to them and start writing down like math or code, right, without explaining yourself. If you explain yourself, you have a much better chance of them understanding where you're going, which has multiple benefits. First, it shows you're good at communicating. Second, if you're going down a bad path, your interviewer will almost always like see that you're going down a bad path that won't work and start trying to give you little clues and hints to help guide you towards something that they think you can get to if you just stop and think about it. And it's really, that's important part of communication as well. Like if you actually listen and pick up on that, that's a sign that you're an excellent communicator, because you're not only your ability to speak, but your ability to listen and hear what they're saying. And it's very often the case that people who are quite good are not good at this particular aspect because it's really hard, right? You have to keep your mind open and your ears open to the feedback to realize that maybe you're thinking about this the wrong way and need to make an adjustment. That's sort of a difficult thing to do in any situation, certainly in an interview. But you know, it's a very, very strong positive signal if a person's able to do that.
Several questions are about your company's expectations on MS versus PhD level statisticians. And a follow-up question is, we do have a good proportion of graduate students here. Should I consider MS versus PhD degree if I wanted to become a data scientist in your company?
So I guess if we're going in order, I can try that. Yeah, MS versus PhD, we hire both. But yeah, and if you look at any of the job listings, that's what it says. That said, you know, I got to be honest with you. I mean, for the Google data scientists, the pretty strong majority of them have PhDs, right? And it's an interesting question. We've had these debates over the years. Why do you really need a PhD, right? And I think Martin's point is probably the one that I would subscribe to, which is that maybe the stuff you learned, like the narrow expertise that you have may or may not be applicable to Google or to your job role. But the fact that you've taken something fairly abstract and worked on it over multiple years and produced some results that pass some quality bar, I mean, that's a pretty big deal. I mean, how many people flame out of a PhD? Now, I'm not saying you should always do a PhD. PhD is very costly in terms of time. You have to care about it. But it does require a certain level of fortitude, and that would serve you well. So it's an indicator of something. I'm not saying you get a PhD just to get a PhD. It's probably a terrible idea, right? But if you did, there's a lot of value there. That said, a master's degree at Google, yes, we have Google data scientists. It's also more common, I would say, slightly more common to be a product analyst at Google with that. But then you do need some work experience because we don't hire it with a master's degree straight.
Yeah, very, very little to add to that. Most of our data scientists are PhD levels, but of course there are exceptions.
Yeah, we hire both. I would say if your goal is to be a data scientist in industry, I probably wouldn't just do a PhD, you know, just because you want to achieve that outcome, because that is a very long, painful way to get there. I would do a PhD if you have other reasons why you want to do a PhD. That being said, if you're, you know, kind of 9/10 of the way through a PhD, or you already have a PhD, don't feel like that was wasted time. It definitely looks great, right? For all the reasons that Martin and Amir are pointing to. You know, the ability to carry something like that out end to end is a very, very strong signal that you're able to work independently and be proactive in solving problems and figuring out what is the way forward, which is like, in the end, I think the most important thing about a PhD.
The next question is about how do you identify job opportunities for yourself? So the questions asked, the data science program I'm in now has 3 specializations, which are health, general data science, business. I'm struggling to figure out what type of job titles in the real world company that are associated with each specialization.
So I'm not going to be very useful here. I'm sorry, I don't really know the lay of the land out there. I can answer for Google, but I don't think I'm qualified to answer more broadly here.
I think this is a case where passion is more important than narrow optimization. Thinking about these specializations, my intuition is you'll have a lot more long-term success if you focus on what legitimately interests you and you find appealing, and it will keep you noodling about data in the back of your mind, long after you should be asleep. Trying to narrowly target your education to meet a particular employment goal, I just personally don't think is the right strategy. The goal is to do something that you really enjoy and then find the right opportunity.
I guess I would have to just agree with that. I don't know the details of the program and how the the kind of course and preparation differs, but I presume that the health specialization is probably logical if you want to work in health science industries, right? That being said, it's not like I would ever look at a applicant and say, oh, well, you did the specialization in health data scientist, not general data scientist. So why are you here? I shouldn't even consider you. No, I wouldn't even cross my mind to worry about that. It would just be looking at kind of what are this person's core competencies and skill set.
Could you talk about what got you interested in niche area causal inference experimentation?
I guess that's addressed to me, maybe. Causal inference experimentation. So I graduated with my PhD in 2000, right? So that's a long time ago. And at that time, the dogma was basically that you can't make any inference without randomization, right? Causal inference is only allowed with the randomization. This is what Fisher said, and he fought that to his dying day. Fought for that. However, in the background, of course, the economists were doing all sorts of stuff using instrumental variable analysis, what have you, and Don Rubin was doing work which I wasn't aware of, right? The Rubin causal inference. I think what happened. So I'll tell you, I was running a team of data scientists at Google, and we were really good. We were really good in the following sense, that if you came up with a question, you said, okay, I don't have randomized data, but here's my situation, we could figure out ways to rip that, right? We'll find you 5 reasons why it could go wrong, right? And that's a parlor game at some level, because sometimes you need to make a decision and you can't do a fully randomized experiment in the way you want to. And I realized that we were basically dead in the water. We were deer in the headlights. We could not answer that question. So guess what would happen? People with a lot less thoughtfulness would say, yes, I can answer that. And they would go and answer that. I'm like, okay, this is a problem. I need to figure out how to find a solution. So I spent some time trying to find people from, let's say, sociology, where they have, or psychology, where they do structural equation modeling. That didn't work. I tried to get some econometricians, and my team kind of beat them up. They weren't able to sort of work. I mean, just the assumptions were like so specific that it was hard. And so then finally I found Rubin. I said, okay, I need to hire his students. And in fact, over multiple years, I started hiring people from his department. And then, of course, more people since then have been graduating with these degrees. The nice thing about Rubin was that he spoke the language of statistics, right? It's Bayesian in statistics. And so it didn't come out at these people in a different way. So he made it credible. I mean, it's not that the econometricians are doing something completely different. And today, Imbens and lots of people, Imbens just got Nobel Prize. So, there are things like that going on, but they spoke in an alien language, and it was hard for us to sort of carry the day. So that's how I got into it, because you can't always make decisions, you can't always get the randomization that you want. So as I said, we created a problem for Google by getting us hooked on experimentation, that was my first job at Google. And we built great experimentation systems at scale. And I'm sure Martin's team does the same at Netflix and more. But then there's the other stuff that we can't, and so that's why it was a balancing act, and I got interested in that.
Just to add two things to that. First, the general comment that came up here is like, if you are in a data science role and someone comes to you with a data problem and your answer is, well, I can't answer that, you should assume that they're going to go do something that's not going to be as intelligent as what you can do. So in a private sector position, you really have the responsibility to be the expert on data. And if you say no, that's probably not the right decision. The right decision is, that's hard. Let me think about how ugly this is going to get and what I can deliver for you. And the other thing I'd like to add is, I don't view this as a niche area. When I think about randomized controlled trials or A/B testing at scale, this is becoming progressively more commodified. There's like 15 startups that are trying to deliver, plug and play platform solutions across a variety of, different business areas. So when I think about a place like Netflix, like Google, like Meta, what will keep them having like a strategic advantage with respect to how we can learn to make our products better? I think that non-fully randomized causal inference, observational causal inference space is going to get progressively more important over the next 5 to 10 years. That is a hunch, it's intuition based on some amount of data.
Thank you for the perspectives, panelists. Next question. Can you talk about each of your respective policies with regards to veteran hiring?
Sorry, I don't have a specific answer to that. I can't tell you. I'm certain that there is something, but I just don't know what it is. I apologize.
Yeah, I have to say the same and apologize. I don't know exactly what the company policy is with respect to veterans and hiring, but I am confident that there is something. I just have to review what it is, and I don't want to misspeak. So it's something I'd be happy to follow up with anybody on. I would want to just talk to one of our hiring managers to make sure that I understand correctly what that is.
Yeah, sadly, same response from me as well.
So we're approaching the end of our webinar, and I'd like to ask, let's say there is an outstanding candidate who received 3 offers from, it is basically all of your companies, from Google, from Martin's team, and Elliot. Can you provide one reason? There are multiple, obviously, many reasons. Can you provide one reason to persuade that candidate to take your offer?
God, what kind of a question is that? Okay, look, I mean, these things are just personal choices, right? I mean, so for example, a lot has to do with the products. The reason I would work for companies because I like what they do. That's probably the best reason, right? If I'm watching lots of Netflix all the time, I love it, then I might do that. If I use Meta and I do it all the time, Instagram, whatever, I might do that. If I'm a Google user and I love that, it's really a question of passion, I would say. Obviously, the role offers have to be similar, right? If you get very different offers, you might consider otherwise. But I think there's a danger, and by the way, I really enjoyed Martin's personal narrative because we're talking about things in aggregate, right? But really, you are not an aggregate. You're an individual. Your career is one of a kind, and I think it's important not to do what works on average, and what works for you is sort of. I mean, we can give you generic answers, but you really got to do what works for you, because that's what's gonna get you excited, get you motivated. And I think so. I would choose based on whether you like the product. I mean, luckily these are all consumer products, so you can have some experience for these products. If you really think that's great, if you like the company, if you like the people you meet, you should evaluate. By the way, you should absolutely evaluate the people interviewing you. If they don't treat you with respect, I mean, that's it's a problem. So all that stuff, and see the experience, see how that goes. And I wouldn't worry about a few bucks here and there, but if they've got to give you good offers too, right? Otherwise, why would you take them? So,
thank you.
Yeah, I think this is zero-sum view, and it's like an employer-centric view. I think it's better in these situations to view it through the candidate's eyes. So when, as a hiring manager, when I'm in that situation, I actually don't try to convince people to work at Netflix. I try to have meaningful conversations with the candidates about what their motivations are, what their interests are, and to be really honest about how much that aligns with the opportunities that we might have versus other places. Because I think in the long run, hiring managers and companies do better if they get the right candidates into the right jobs. It could be that right now, the right job for that candidate is on Amir's team or Elliot's team. Maybe a couple of years down the road, if we've treated that candidate with a lot of respect, maybe then Netflix is the right opportunity for them. So that's how I view those situations.
I think it's a good situation to be in. Most people who are in that situation leverage it to maximize the compensation, right? And if you're in that situation, then I guess I encourage you to do that. But that being said, I wouldn't put dollar compensation above all other considerations. It doesn't really, like, that's not a good way to optimize for your own happiness. I think in addition to understanding the products and you know, whether or not you like the products, you definitely want to do your homework on the internal company culture for any company that you're going to consider joining. You can get some sense of that from the way you were treated in the interview, of course, but also I would encourage reaching out to anyone you know who works at these companies, or you know, even just searching online to learn what you can about internal company cultures, because they are all different and they are, you know, it really is a personal thing, right? Like some people really like one type of culture versus another, and it's hard to, you know, one size fits all that.
All right, so this is the end of our webinar, and thank you very much for your participation, and we appreciate your time and insight, and thank you very much.